Hello PLP Geometry. Welcome to Unit 1, Video 4 on congruence and bisectors, focusing on segments again. Alright, so again, this is going to be more vocab for Unit 1. I know there's a lot. Try your best to keep it straight. Again, use those delta maths to keep practicing, to keep yourself fresh, right? So again, we're still in Unit 1, Intro to Geometry. So this is video number 4. Again, we're going to look at something called congruence, which is a huge idea in this class. Congruence. We're going to look at bisectors. Bisectors. And again, this is going to be a focus on segments. So I could get worried about time, so I start to write faster, so I apologize. But again, I'll try my best to keep things slow and legible. Just bear with me if it adds an extra minute to things. Okay, so the first thing we're going to talk about are what are called congruent segments. Congruent segments. You are going to deal with congruent segments all year long. So congruent segments are segments with the same length. Segments with the same length. I'm going to fit it length. All right. So when you have two segments drawn and they look about the same. So I'm going to let's draw AB going this way. And then let's have fun and let's draw a CD going this way. So CD going this way, right? Just to make sure we know they don't have to be the same. Now they should be about the same length. So if we want these two segments to be shown congruent, we're going to put what are called tick marks. Tick marks on the segments themselves. So one tick mark, one tick mark. Those two segments are congruent. Two tick marks, two tick marks. Those two segments are congruent. So again, in a picture, you're looking for the equal number of tick marks on segments to see if they're congruent or not. What we would write is we would say, based off this picture, that segment AB, there's the segment AB, and then the symbol for is congruent to is an equal sign with a squiggle on top. I think it's called a tilde, is congruent to segment CD. You could also put that segment CD is congruent to segment AB. That order doesn't matter. Either way you slice it, what this is telling you is that these two segments have the same length. That AB without the bar, the length of AB is equal to CD without the bar, the length of CD. So again, keep in mind the difference between saying segments that are congruent and their lengths are equal. Okay, so let's go into the bisector idea, and to do that, we're going to start with a word called midpoint. So I'm pretty sure you can guess what a midpoint does. So a midpoint is a point dividing a segment. Point dividing a segment into two congruent segments. Now these are your notes, right? But one thing that I like to do, and I'll do it as we go, is I like to use symbols in shorthand, right? When you're taking notes, the reason sometimes it takes a long time to take notes is because you write down every word. So instead of putting the word congruent here, I could have just put the symbol to congruent segments. So again, be aware that you can use that symbolism to stand for words. And again, it's your notes, you're writing it your way. So let's draw a segment PQ. So here's P, here's Q. I'm going to put M right smack dab in the middle. If M is right smack dab in the middle, then that means that the length from P to M is the same as the length from M to Q, which means that segment PM is going to be congruent to segment MQ. So notice that to show that something is a midpoint, you need to make sure you mark either side of that midpoint on that segment congruent to each other. So we would say here that M is the midpoint, of segment PQ. And if M is the midpoint of segment PQ, then that means that it splits it into two congruent segments. Segment PM is going to be congruent to segment MQ. And knowing what congruent segments are, that means that the length of PM is equal to the length of PQ. All right. Now, there's a couple of things to keep in mind. I'll put a little star here. So because M is the midpoint, that means that each of those smaller segments is half of the bigger segment. So that means that the length of PM will be half the length of PQ, and the length of MQ will be half the length of PQ. So keep that in mind. Okay, last but not least here. So when you have a segment with a midpoint marked, and you have a line, segment, or ray going through that, that is called a segment bisector. Segment bisector. So a segment bisector is a line, again this is OR, sorry, bisector, is a line, a segment, or ray dividing a segment into two, and I'm going to do it here, into two congruent segments. So again, if you need to write the word congruent, do it. But I'm going to put this symbol into two congruent segments. And that means that it passes through the midpoint. So if I draw this picture of segment PQ again, so here's P, here's Q. I'm going to put that M midpoint there. But now I'm going to draw a line. Oh, let's mark the two pieces congruent. But now I'm going to draw a line through M. And remember, you can label the points on the line or that single letter. I'm going to put a single letter right here called L. So when you see this picture and you see line L going like this, and you see those two congruent markings on either side of M, this means that line L is a segment bisector for PQ, and it means it creates two congruent segments on PQ. So again, when line L, so we have line L bisects segment PQ. What that means is M is the midpoint of segment PQ, and what that means is PM is congruent to MQ. And there we have it. So that is what a segment bisector does to a segment. Okay, thanks for watching. Again, I know it's a lot of vocab, but the better you can get at this, the better the year will be. All right. Again, thanks for watching. Good luck in your practice.